Okay, the next thing we want to talk about is this time series decomposition. And so basically what you may recall from your textbook is that forecast can be broken down into different segments. And so your textbook shows how you can do kind of a seasonal variation, and I think that's shown on page 64 and 65 of your textbook. We're going to be working on this decomposition using the least squares regression because I think it's a little more complicated. And so we're going to be starting, that kind of starts on page 66. So we have to first, again, the time series can contain one or many elements: trend, seasonal, cyclical, autocorrelation, and random. And identifying those elements and separating the time series data is known as decomposition. Okay, and so we've got seasonal variation, which either can be additive or multiplicative. Okay, so you can see the additive just says that over time we continue to grow our forecast. The multiplicative says over time we continue to grow our forecast, and oh, by the way, our variation, our seasonal variation gets larger. Okay, and so again, this is how to do the seasonal factor. It's really straightforward. You take the average across however many time periods you're looking at, and you divide the actual divided by the average, and that's going to give you your seasonal factor, and you use that as you're then predicting moving forward. Okay, for what we're going to focus on in this YouTube video is the decomposition using the least squares regression. Okay, and we're going to decompose the time series into its components. We're going to find the seasonal component, deseasonalize the demand, and then we're going to find the trend component. Then we're going to forecast the future values almost by reversing that. We're going to then project based on the trend component and then adjust it based on the seasonal component. Okay, so again, here's the example from the textbook. This on the textbook that I have is on page 67. We're given this information, right? We have 12 time periods, and basically it's 3 years of 4 quarters for each year and the actual demand for each of those. So we identify our seasonal component by, so for time period 1 or quarter 1, we take the demand from each quarter 1, 600, 2400, and 3800, and divide it by 3, okay? And that's going to give us a value of 2266.7, okay? And that's going to give us then the average of the same quarters of each year, okay? The average then for time period 2 is 1550, 3100 plus 4500, okay? And we divide that by 3, gives us 3050, okay? And then for time period 3, it's 1500, 2600, and 4000 divided by 3. For quarter 4, 1500 plus 2900 plus 4900 divided by 3 gives us 3100. So that's the average of each of those seasons, okay? Then we determine the seasonal factor by dividing that average by the average of all 12 quarters, okay? So we would sum these up and then take the average, or dividing it by 12, and that's how we would get this. So in this case, our 12 quarters, this column, column 3, adds up to 33,350. We divide that by 12, and that gives us 2,779 is the average demand per quarter. So to get our seasonal factor, we take the average demand for that quarter, 2,266.7, divide it by the average demand across all quarters of 2,779, and that's going to give us 0.82. Doing the same thing with 3,050 divided by 2,779 gives us a seasonal factor of 1.1. Okay, and doing the same thing for quarter 3, average demand for quarter 3 of 2,700 divided by 2,779, average demand across all quarters gives us a seasonal factor of 0.97, and again for quarter 4 it's 1.12. All right, if you have a little trouble with that, just go review step 1, determine the seasonal factor index that's shown on page 67. Okay, and then now that we've got that seasonal factor, we don't have to recalculate it for year 2 and year 3. We just repeat it. Quarter 1, seasonal factor 0.82, 1.11, 0.97, 1.12, and then we repeat it again for period 3. Okay, so we need to deseasonalize the original demand. Okay, so our original demand is 600. To deseasonalize it, we divide it by the seasonal factor. So we're taking out the the issue of our seasonal demand. So we're taking 600 and dividing it by 0.82, 1550 divided by 1.1, 1500 divided by 0.97. So you can see it's just column 3 divided by column 5, right? And that's deseasonalizing the demand, okay? As we move forward, right, if we're going to do linear regression, we're going to need t squared and t times y. So we go ahead and add in columns to do that. Okay? All right, and we can also then transition this into Excel, and we're going to develop a least squares regression line for the deseasonalized demand. So we're going to take that deseasonalized demand, which if you recall comes from column 6, right? And we're going to have our time periods where we currently have 1 through 12, and we're going to predict 13 through 16, right? And there's our deseasonalized demand. Just like what we did in the linear regression, we input this is our y data, this is our x data under data analysis regression, and we're going to come out with our slope, right, is going to be 342.18, and our y-intercept is going to be 555, and our standard error is going to be 512. And then we can use that information then to predict time period 13, 14, and 13 through 16 by using our y is equal to a plus b times t. Okay? Okay, so we then transition. Here's what we predicted based off of linear regression. Okay, quarter 1, 2, 3, and 4. That's what we predicted based off of linear regression. Here's our seasonal factor, and now we're going to take that prediction and multiply it by the seasonal factor, and now we're going to again adjust the regression line by that seasonal factor. Okay, so that's how we do that in theory. Okay, and so you should be able then to do that very same thing when you're working on your Connect homework. All right, and I'm going to go ahead and go to the Connect homework. Okay, I've got Connect opened up to a couple of problems here, and let's go ahead and go to 322, right? And so it's listing this Zeus computer chips used to have major contacts to produce the Centrino type chips. The market has been declining during the past 3 years because of the dual core chips, which it cannot produce. So Zeus has the unpleasant task of forecasting next year. The task is unpleasant because the firm has not been able to find replacement chips for its product lines. Here's the demand over the last 12 months. Okay, so we've got, here's the demand over the past 12 quarters. So we've got quarters 1 through 4 from 2 years ago, 1 through 4 from last year, and 1 through 4 from this year. Okay, and so what we need to do is we need to put that information into Excel. All right, and so I'm going to do that by just copying and pasting what I've got here. And let's do that. And then what I want to do is I'm going to go ahead and kind of revise the format a little bit. So this is actually 2 years ago where that begins. And then here's what we're going to do is we're going to take last year, put it right below it because we want that in a line. And we'll change those labels up. And I want to format these cells just to make sure that they're in a number format. And sometimes it doesn't want to change, so let me see what we can do about that. Still didn't do it, so I'm going to copy and paste it. I'm going to go paste special, and I want to do values. And now let's see if I can change that to be a number. Still didn't like it. And so sometimes when I struggle with that, there is a way, and I'll work on trying to get that better, but we'll just kind of repeat. We'll just type over it here so that we can keep moving. Okay, so I've got 4785, 3485, 42, should be 4285. That would probably give us a problem down the road. 2985, 3485, 2685. I must have trouble with my 2s and 5s. 3485, 2385, 3185, 2185, 2685, and 1685. Okay? And I'm going to go ahead and clear the contents on that. All right, so as we start this process, then the first thing that I need to do is I need to come up with my average from the same quarter. Right? And so if I'm going to do that, I'm going to take the average, or the amount from quarter 1 2 years ago, plus the amount from quarter 2 from 2 years, or quarter 1 from 1 year ago, and the amount from quarter 1 from this year, and I'm going to divide that by 3. Okay? And I'm going to do the same thing, and I should just be able to copy it down because they're all in the same, they're reference-wise, they're all in the same spot, so I can just copy and paste that formula down. Okay, so that gives me a 3,818 for the average for the first quarter, 2,785 for the average for the second quarter, 3,485 for the average for the third quarter, and 2,351 for the average for the fourth quarter. Okay. Then I also need the average from across all of the months. So I'm just going to go average, and I'm going to collect the average from all of these months, right? And that's going to be 3,110. And let me go ahead and wrap that text, center that up. And then I can figure my seasonal factor. Is going to be the average from those quarters divided by the average across all the months, right? And if I go scroll that down, oops, that doesn't work because I need to fix that cell reference. Now let me try to copy and paste that down. Okay. The other thing that I would encourage you to do, so now I have my seasonal factor, all right? And I can take the average, and if you look down here, it's going to tell me the average is 1. If you've done your seasonal factors right, they should average out to 1 or 100%, okay? And so I'm going to take and I'm going to go copy, and I'm going to paste those again. And I just want to paste the values, so I'm going to go paste special values. Didn't work so well for me. Should have. Let me think about that. Copy. So I'm going to go copy, paste special, and I want to use values and number formats. There we go. All right, so now I've copied my seasonal factor across all. And I just to remind you, it does say in the Connect homework, it says, do not round intermediate calculations, round your answers to the nearest whole number. So my intermediate calculations are everything that we're doing here. My final answer is going to be that forecast that we're going to come up with. All right, so we've done our seasonal forecast. Now to de-seasonalize the demand, if you remember, what we do is we take the actual demand and divide it by the seasonal factor. So de-seasonalized demand is going to be this divided by this. Okay? And I'm going to do that for each time period. Okay, so that's our deseasonalized demand, and then I'm going to get my t squared, which is going to be my time period, and I need to adjust that because I need to go 1, 2, 3, 4, and continue that down across all of those. Okay, and so to square that, I need to go time period 1 times time period 1. And I'm going to do that, just copy that down for each of them. Right? Okay. And so I'm going to sum up, I'm going to have the sum of my deseasonalized demand. I'm going to have the sum of my t squared. Right? And then again, when I'm working with regression, I need to have that t times my deseasonalized demand. So again, let me label that again for when we did regression, it was t times y. So in this case, it's going to be t times y, and our y is our deseasonalized demand. Okay, and so then I have my total on that. Now I can keep working this through, right, in terms of manually calculating y and the slope and the intercept, right? Or I can actually then take this deseasonalized demand and just take this information and do a regression analysis on it, okay? So let's go ahead and go to data, data analysis. Let's do regression. Okay, my y range, right, is my deseasonalized demand, and my x range, right, is going to be my time periods, and my output range, I want to be right here, and I should be able to hit OK, and it's going to tell me then that my intercept is 4,183.08, and my slope is a negative 165.09, and my standard error of estimate is 251.96. So that being said, if I want to then calculate demand for time periods for next year, right, let me just kind of give this a little, we're going to go next year, and it's going to be, instead of 9, 10, 11, 12, it's going to be 13, 14, 15, and 16, okay? And so I'm going to take and go that this deseasonalized forecast we're going to use linear regression, so we're going to say that it's going to be equal to the y-intercept plus our slope times our time period. Right? And so I can do that. Again, for time period 14, it's going to be our y-intercept plus our slope times our time period. Okay, and if I just want to copy and paste that down, I just need to fix these cell references to make them always refer back to what we have in the table for intercept and slope. Okay, so I should be able to do this. All right, then I need to take my seasonal factor that we calculated. So I'm going to come up here, and here's our seasonal factor right here. I think I'll copy from here because I already got just values in these last four. And then our seasonalized forecast is going to equal the deseasonalized forecast times our seasonal factor. Okay? And there we have it. All right. So we have 2500, 1676, and we have 1912 and 1165. So I think given our plus or minus factors of 3, 4, and 4 and 5%, we should be fine. Again, that's going to have to do with some rounding errors that we see in between Excel and maybe what someone else has done. So looks good, and I just wanted to walk through how that's done. And again, you've got a number of problems that are going to use that, and I think you've also got some demonstrations in Connect in your e-book, so if you want to review some of those, you might find those helpful as well.